allocated the key concepts of this technology into our group members. First, the Ecenur is going to talk about the autonomous vehicles definition and the automation levels. And then Sinan will introduce the technical information of autonomous vehicles. And then İlter will inform us the software of autonomous vehicles. And then I will continue as startups and the future of this technology. And then we conclude our presentation. The autonomous vehicles concept is a wide range topic. In our presentation, we prefer cars since it is a part of our lives. Right, we'll give floor to the Ecenur, who will talk about this presentation.
This is the development chronology of autonomous vehicles. The autonomous vehicles story started in General Motors in 1939. These pictures are represent the building and the first products of GM company. If anyone wants to examine this chronology, I can send it. Well, what is an autonomous vehicle? Autonomous vehicle or driverless vehicle is one that is able to operate itself and perform necessary functions without any human intervention. Autonomous vehicles have 6 levels, and a table shows these levels, and to strengthen the understanding of the automation levels, I will explain one by one. At level 0, the car has no control over its operation and human driver does all of the driving. At level 1, the vehicle can assist with some built-in functions, but the driver still handles all accelerating, braking, and monitoring of the surrounding environment. The level 1 provides adaptive cruise control, which helps the driver to maintain a safe distance between our car and the car ahead of you by using the radars or cameras to automatically apply brakes when traffic slows and resume speed when traffic clears, and also lane keeping assistant to help with driving tiredness. This is interesting information. The cruise control was invented by a blind mechanical engineer named Theodore. At level 2, and the driver has to remain fully engaged with the driving task, but you will notice the gradual transfer of control from human to machine, which is referred to as an advanced driver assistance system, in which the vehicle can control both steering and accelerating, decelerating. At level 3, vehicles have environmental detection capabilities and can make informed decisions for themselves, such as accelerating past a slow-moving vehicle. The vehicle itself controls all monitoring of the environment using the sensors like LiDAR. The driver's attention is still critical at this level, but it can disengage from safety-critical functions like braking and leave it to the technology when the conditions are safe. At level 4, the vehicle system is able to perform all driving tasks independently in certain conditions in which human attention is not required. For example, Waymo is a level 4 self-driving taxi service in Arizona. The cars picking up and dropping off passengers in Chandler without a safety driver in the seat for more than a year and over 10 million miles. Finally, level 5 involves full automation whereby the vehicle is able to perform all tasks in all conditions and no driving assistance is required from the human driver. This full automation will be enabled by the application of 5G technology, which will allow vehicles to communicate not just with one another, but also with the traffic lights, signage, and even the roads themselves. NVIDIA is the leader in this category. They have been developing designing embedded supercomputers platforms, which they call NVIDIA Drive AGX, which act as a brain of the car. Cars with these AI platforms are capable to achieve level 5 autonomy, where drivers have to simply plug in their destination and leave the rest up to the vehicle itself. And now we'll talk about the technical details.
Thank you, Ece. The first thing I want to talk about is block diagram of autonomous vehicles. Role of this environmental sensor is to provide comprehensive information about surrounding objects around the vehicle. On the vehicle, various types of sensors are implemented, which provide information from near, medium, and distant range. At the perception part, vehicle collects data from various sensors. Then the vehicle decides according to given rules to control such as speed, acceleration, and brake. Sensors for autonomous vehicles. I want to give information about these sensors, which are cameras, LiDAR, and cameras for autonomous vehicles. In autonomous vehicles, CMOS and cameras are used. In CMOS sensors, photons are converted to voltage separately at each pixel. Several transistors located near each pixel serve to measure and amplify the signal from each pixel. The advantage of this arrangement is that the data collection process takes place in the whole chip. In the figure, the CMOS sensors convert the charge of each pixel into an electrical signal directly on the chip. Another thing is car cameras can be classified in several ways. The most important aspect of classification is the location of the camera. In most autonomous applications, they are implemented as a front or rear cameras. Another classification is based on color, black and white. The color of the sensed environment affects the reliability and precision of the same camera function. Although most of the key features can be secured using a black and white camera that captures only the brightness level of each pixel. By adding at least one color, the significant improvement can be achieved. For instance, by using red pixels, the identification of traffic signs can be more reliable. LiDAR measures the distance to a target using active sensors. It fires rapid pulses of a laser light at a surface. When the light hits the target object, it is reflected back to a sensor which measures the time taken for the pulse to bounce back from the target. The result is precise three dimensions about the target object and its surface characteristics. For instance, in the case of self-driving cars, LiDAR used to generate huge 3D maps that the car can navigate. It is also used to detect pedestrians, traffic signs, and the other nearby obstacles. Last thing I want to talk about is radar. Radars used in the vehicles responsible for detecting objects around the vehicle and also serve to detect dangerous situations. Object detection and detection of hazardous situations to alert or warn the driver can be used. Radar sensors work on the principle of evaluating the difference between transmitted and received reflected signals. With the measured elapsed time and speed of sound wave spread, it is possible to calculate the distance to the detected object. The measurement of the relative speed of the detected object to the vehicle is based on the Doppler effect. Based on the phase shift and the frequency of the reflected wave, the speed of the detected object can be calculated. Radar systems in autonomous cars work in two bands, 24 GHz and 77 GHz. Now Ilter will talk about the software part of the autonomous vehicle.
So Sinan explained about the technology at hardware side. So what about the software side, which makes the car self-driving? We utilize software for autonomous vehicles in three stacks. First one is sensor fusion, the second one is mapping, and the third one is softwares for line detection and cruise controls. So first, what is the sensor fusion? Sensor fusion is, we already mentioned that, the pros and cons of LiDAR and radar. So how are the sensors used in autonomous vehicles? Here comes the sensor fusion algorithm. The Kalman filter is one of the most popular algorithms in sensor fusion. Kalman filter, and with the help of the Gaussian elimination and distribution, we utilize them to make sensor fusion. With these, we will have a crucial result to decide how many meters from the car to an object by eliminating the noise of the two sensors. Also, we create a map, which you can see on the left. And the second one, localization. Localization is how we determine where our vehicles is in the world. GPS is only accurate within a few meters, but in this case, we need a single-digit centimeter level accuracy. That's why we located the car, then started to watch with 3D camera and put another map with LiDAR and radar and sensor fusion algorithm on the right-hand side. If these maps are matched at the end of the experiment, that means our map is accurate. And there is another part that localization occurrence could be affected. Light can affect the camera lens in a wrong way. So how we make accurate in localization map? To solve this problem, LiDAR and radar localizate in the car to each individual map layer and also used fusion, the individual per sensor. That helps to generate localization confidence metrics based. But I would like to mention on this photograph, there is a blue dot. It's come from radar and fusion algorithm. That means the car in front of our object, and the green lines, which comes from radar, it measures the distance from our object car. And another main part is data. As you can see, autonomous vehicles get 4,000 gigabytes data each per day, which needs to be cleared, processed, stored, analytics, and also used for deep learning. Why the data collection is important? Data helps us to make localization like roadmaps, and it decreases the time on while IoT devices calculate the process, and also it can increase our accuracy on decision making. So how we do manage this process? With the help of the IoT and cloud technologies, this process can be full automated and serverless. To make it happen, we use databases, analytics, deep learning models, Lambda functions. And if we look at this architecture on the left-hand side, we can see that we have IoT devices on the car. And the middle side is the AWS cloud architecture. And the right side, the notification service, which is called notification services, Lambda function to UI that interact with user. And as you can see, we're in the middle side of the cloud operations. We can detect an anomaly detection, trip data, driver safety score, diagnostic trouble codes, also location-based marketing for companies' beneficiaries. And I will explain a basic algorithm for line detection with Python and OpenCV. And the first step is Gaussian blur. After reduce noise and smoothen out of the image, we basically making an array for pixel intensities changing pixels. So image shows a strong gradient on the left-hand side and weak gradient on the right-hand side. After that, at step 2, we use Kenny edge detection algorithm. It's an algorithm to detect edges in our image. A change in intensity of pixel will give us an edge. And after that, we can see this image. And the step 3, half transform. This is the main part because it shows us the region of interest that car interacts with the road. Detecting the region of interest includes line with bitwise calculation. You can see zeros and one. And with bitwise AND operator, white side is the region of interest. And we take this region of interest from the image. After that, we get in the lines of the image. After using half transform and bitwise calculations, and give a color what you want, you can clearly detect your lines. And after all, at the end, you can combine your algorithm with the first image, the real image, you can detect lines, and if you make it loop, you can use it forever. And it's a little code I uploaded on my GitHub account. You can check this out. And okay, we learned the basics, but how we could practice ourselves in this area, especially in pandemic from our homes. Here's a good example. I would like to mention ComAI. Interesting fact that ComAI is an open source startup, which you can jump into their product on GitHub account. Also, ComAI chooses its interns depending on contribution on the repository. That means if you learn or if you use Python and OpenCV, you can contribute and get an internship from remotely. And there is another fact that I would like to mention. ComAI's product UI looks like our little experiment. So it will use its uses in the real world examples. Therefore, Tolga will tell us about startups and feature in this list.
And thank you for your speech, Ilter. Right now, I would like to give you some brief information about the top 5 autonomous vehicles organization, which are Tesla, Waymo, Argo AI, GM Cruise, and Mobilize. To begin with the Waymo, Waymo is operating in only Phoenix, and there are 600 vehicles, and they map an area of 1 square miles by using LiDAR. They updated the level 4 and they are trying to reach the level 5 in a couple of years. The company has driven 35 million miles in the real world and 16 billion miles in the simulation. For GM Cruise, 200 vehicles are tested and driven 1.2 million miles in a real world. GM Cruise also use LiDAR and radar, both of them. They are in level 2 stage, but the good thing about the GM Cruise is that people can control and monitor their vehicle by using their cell phones. The third company is Argo AI. They tested 100 vehicles in 6 cities so far in the USA. They will not produce its vehicle. They will manufacture self-driving technology for other company. The last but not least, Mobilize and Tesla are the frontrunners of this technology. But Tesla has more vehicles compared to the Mobileye. Tesla has 1 million vehicles and each vehicle collects data from the surrounding approximately as 1 mile per month. And when we multiply by the 1 million vehicles, and the result is 1 billion per month. And when we convert into a day, it is approximately as 35 million, and no one can reach this number. What else will self-driving technology change? AV impact on our daily life in 3 parameters. These are time, money, and the space. For time, according to research on Americans spend an average of 293 hours a year driving, and this is a waste of time, and it is approximately 7 working weeks. By using AV, we can do our jobs while driving. And the second one is space. Because of the vast amount of the parking places, we can convert these places into more green places. And according to this, we can lower the infrastructure money, and utility of the transportation will become more useful. And the third one is money. Transporting things become more cheaper and more safe and more fastly. By using this picture, according to my perception, for example, because driverless vehicles will drop off passengers and move on, prime real estate now consumed by vast parking lots and unsightly gardens could be freed up for more housing, parks, open places, and public places. Autonomous vehicle could increase car sharing, which would reduce traffic congestion and air pollution. Because the technology will allow this vehicle to travel closer together, they will take up less lane spaces. Moreover, that cities could also could also use the extra space for bikes and also the wider sidewalks, and this making the walking and biking more safe and more appealing from my perspective. But one challenge, what will we do with time, money, and space freed up by self-driving? We'll see in the future.